Hello, good afternoon. My name is Rony. I spent many years here at the lab before my co-founder Nathan and I started Tulip about 3.5 years ago. So let's take a short little journey into the land of the future of manufacturing. This is this glorious piece of stock photography is what I think a lot of people imagine the factory floor to be like, even today. It is fully buzzword enabled. It has many three-letter acronyms that are tied to it through the MES, PLM, ERP, blah, 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 blah. It's got your blockchain, it's got your deep learning. But now I'll take you back to the present, and this is more of what I see when I go visit factories. And what we are trying to do at Tulip is build this new class of software, a thing that we call manufacturing applications. And so sort of the context for all of this is that in the manufacturing world, for the most part, the kind of user interfaces that are used by operators and lines are terrible user interfaces because they're not designed for people, they're designed for the machines themselves. And this is happening in an environment which is extremely complex. Necessarily complex because making things is tricky. So the tools that the engineers have to work with are still in the analog days. A photo like this is something that I see in literally every factory I visit. A stopwatch and a clipboard to measure very important, critical timing information that you use to optimize your factory floor. So when you start to get all this data together, it's very hard to put it all together. You go from analog to analog, or you have to go analog to digital to some kind of digital silo, and that sucks to try to get something out of it. So there is a nice 15-step process to solve all this problem, but as you can imagine, it can be a little bit time-consuming to get there. So what we're trying to do at Tulip is build this new kind of software for the manufacturing floor, one that is around this notion of small applications that are made by the manufacturing engineer that is enabling that kind of process, the kinds of processes that you see on the floor. Enabling it by collecting information about real-world things that are happening, sensor data or tools that are on the floor. These applications can bake in all sorts of quality checks in order to ensure that the operators are doing the right thing. And these applications are designed with the operator first. So in contrast to that kind of wall of switches that you might see beforehand. So bringing the human into the center of the system. Now, once you start having these applications on the factory floor, you end up generating a ton of data that's coming both from machines and from sensors and from the people, and you can put all these things together in a way that an engineer can answer the questions that they have very, very quickly through a kind of an exploration into the data. There is, if many of you probably are making things, and you may have heard a lot of stuff about machine learning and predictive analytics and all this, it's all the buzz. But for a class of problems that are happening on the floor that involve people, fundamentally, as someone who did a PhD in machine learning, I don't really believe that machine learning has a kind of place yet in these kind of shop floors because there's a lack of data about what's happening. And when you have, especially in those kind of environments where you have every day you might be making something completely different because we are now in a state where the products are changing so fast. And you have 50 stations in the factory, and each one of those 50 stations is doing something completely different. That can be really challenging to try to get some kind of meaningful result out of the kind of classic machine learning approaches. What instead we believe you need is the right kind of tools for the engineer to be able to dive into the data that is in there and use their own experience in order to get some kind of interesting result in order to improve the process. So what do I mean by these kind of apps? Like, they fall into a variety of different categories. This is just a couple of examples of things that our customers have started to put together. And these apps can be something that is deployed on a mobile tablet. Someone's walking around and doing an audit on the floor. They could be something that's at a workstation where someone is doing a maintenance operation, a machine changeover operation, an assembly operation, and giving some kind of guidance that is now connected to the physical world. So why you might care, for the most part, is there's these make more money and cost less to make that money. In short, these kind of things that I'll get to in a moment in terms of the concrete numbers of how we've started to see this now across a variety of different discrete manufacturing spaces, as well as the pharmaceutical industry. So, again, going back to the kinds of applications you can have, everybody is lean in some kind of capacity in their manufacturing operations, or they really want to be. But the kinds of tools that are there for lean really are tied into the physical world. So giving a digital tool that allows them to very easily take a look at historic data can be great, as well as share things in real time. Training applications is another huge thing, whether it be training on some kind of new process that's happening, training a new employee who's coming in, or cross-training employees throughout the facility. You can increase the speed at which people can get trained up and decrease the cost at the same time. Auditing, being able to ensure that you are cleaning that pharmaceutical bioreactor effectively between batches or drugs, or visual work instructions, or making sure that someone is assembling something properly. Machine maintenance and operations, making sure that that machine is put together correctly before it goes into production again. So, these are just a couple of kind of examples of the applications that we've seen delivered. The impacts now have started to stack up across industries from apparel to pharmaceuticals to automotive, electronic devices, aerospace, defense, and we've seen repetitions of similar kind of numbers. So decreasing in the number of quality errors where there's manual operations, effectively eliminating those, so like 99, 100% reductions in manual caused errors. In the example here with Jabil, one of the largest contract manufacturers in the world, in their NPI lines and their flex lines, they've reduced their quality issues by overall 60%, while at the same time being able to produce more. And in the Merck case study that we have here, this is a training use case of being able to reduce by about 60% the cost of training a new employee and doing that in a fraction of the time. So these are a couple of examples that sort of the numbers will speak for themselves. We believe that these kinds of self-serve applications that the manufacturing engineer is able to build, really, like, it's, if you're familiar, if you've ever bought software for manufacturing, it's an extremely long and very expensive process. We believe that that should change. And so we've just announced let me skip overhead on this, this factory kit, this sort of the Tulip in a box, which has an IoT gateway, a bunch of sensors, a licensed software. Then an engineer can get this in the mail, unpack it, build a station at their desk, and deploy it within an afternoon. So with that, we have a demonstration in the back, and I welcome all of you who make things to come and check it out.